What's up, guys? So today we're going to be doing leetcode 135, which is candy. It's a hard and it's the daily for June 1st. Okay, so I'll just get right in. To be honest, I kind of did this one before. I didn't try on it because it's a hard. I wasn't confident enough in my abilities, but yeah, let's just get started. If I can screen mirror my iPad. Okay, perfect. So there's two rules, right? So you're trying to distribute candy to n children. And there's two rules. So each child must get at least one candy, and each child must get, with a higher rating, gets more candies than their neighbors, right? So let's say that the array looks like this: 1, 3, 5, 2. Okay, and these are the children ratings. We're gonna put the minimum. Every child must get one. So here we put 1, but this child has a higher rating than 1. So let's say it gets 2, and then, but this child has a higher rating than that, so this gets 3, but 2 is less than 5, so this can get 1. So we're trying to look for the minimum number of candies we have to distribute, which is basically just the sum of this, right? So it's just 7 in this case. So what we can do is we can essentially try to simulate this entire process. So we have, the strategy here is first we instantiate an answer array like full of 1s. So like first we just assign everyone with 1 candy, because this is just an easy thing to do. It just takes care of this first rule for us right here, like right here. Okay, and now we're gonna think of this second rule in terms of two different things. So this second rule, we can first enforce, like this is kind of just like two rules, right? So we have a like, let's say this is I minus 1 and this is I, like index. Let's say this is x and y. If x is less than y, we're gonna assign y, and this is strictly less than, by the way. We're gonna assign y with a higher candy count. Assign y higher candy. All right, and same thing like for the other side. So if we have I minus 1 and I, and this is x, y, so we're just gonna say if x greater than y, assign y a lower candy value. Right, so how we're gonna tackle the second rule is through 2 passes. So we're gonna do a first pass for A, and we're gonna do a second pass for B. In the first pass, we're gonna enforce that the left neighbor has a correct candy, relative candy amount, and then the second pass we're going to enforce that the right neighbor has a second candy count. So just makes things simple, more intuitive. For like the first pass, right, I'll just write this down here. So 2, like in the first pass, we're going to start from 0, and if ratings I is, sorry, we're gonna start from 1 actually. And if ratings I is greater than ratings I minus 1, we're gonna, what are we gonna do? Yeah, okay, so we're gonna assign ratings, or we're gonna assign child I. I'm just gonna denote this by CI, a higher candy count. And for this, we can just be greedy and say it's going to be like answer at I is going to be answer I minus 1 plus 1, right? And then the second pass, it's basically the same thing with a little another caveat. If we just do this rule right here, right? So if we just do like a similar rule, but we just increment it by 1, we can lose like, if the right child was, like if the neighbor on the right side has like 2, for example, 2 candies, and the neighbor on the left side has like 5 candies, we're gonna do 2 plus 1, which is 3, and that doesn't fit our previous like enforcement of the rule, if that makes sense. But I think you'll see it more when we like actually like code the thing. But yeah, so we start here. I'm just gonna start from the back. Start from n minus 2. This is a little more simple. It's just a little easier for me to follow. But it's more intuitive, like you're starting from the back and you're enforcing that. So we're gonna start from n minus 2. I'm pretty sure you could do this starting from 0. I don't know though for sure. But we're gonna start from n minus 2 if ratings I is, what is this? We're gonna do if ratings I is greater than ratings I plus 1. We're gonna say answer I is equal to max answer I answer I plus 1 plus 1. Okay, hopefully that makes sense. We're gonna go ahead and implement it now in C++ because that's my favorite language. But yeah, okay, let me put this to the side and then let's get to coding. So first, I'm just gonna store the value of like the size, the length of the array in an integer n, and I'm gonna instantiate an answer vector of length n and fill it just all with ones, right? So in the first pass, what are we doing? We're gonna start at 1, and while I is less than n plus, we're gonna say if ratings I is greater than ratings I minus 1. Yeah, I minus 1. What do? We say answer at I is equal to answer at I minus 1 plus 1. Okay, and in the second pass, we're going to say for I equals n minus 2, so we're starting at the back now. While I is greater than or equal to 0 and I minus minus, we're going to say if ratings I is greater than ratings I plus 1, answer I is equal to max answer I plus 1 plus 1. Okay, actually, I'm gonna comment this out. This is gonna be wrong, by the way, but just to see like what I was talking about before with how we need to take, why we need to take the max. Basically, that can be a little. I didn't explain it well enough, so hopefully a test case will explain it for us. And then we're just gonna write a helper method to keep everything nice and clean. Int sum, and this is just gonna sum up whatever's an answer for us. So we're gonna take vector int, and we're gonna pass the address of the array. That's what this ampersand means basically. And this just means like when we call the function, it won't copy it over, which can take a lot of time and take a lot more memory. So we're gonna say answer equals 0, return answer at the end, and we're gonna do a for each loop here. So for each x in the array, we're gonna do answer plus equals x. Okay, and here we're just gonna do return some rating, or not ratings, answer. Okay, so hopefully this works. I don't know what I just did. Okay, but yeah, hopefully this works. Wow, okay. Ratings. That's weird. Oh, okay, I just had a spelling error. Ratings. Okay, yeah. Here you can see, let me print out the before and after of the array. So print x of the answer array. So you can see this a little better. See out x and see out n line. And then we're gonna print it out after as well. See out x. And this is how you, by the way, this is how you print out stuff in C. You use C out. I don't understand that, but I don't know. Maybe it makes sense to some people. But yeah, as you can see in the beginning, right? So everything was basically correct. So we had, because this has a higher rating than 1, we set it to equal to 1 plus 1, which is 2. And we did the similar thing here. And because 2 is not greater than 5, it's just 1, right? Nothing changed. But in the second pass, like right here, we said because 2 is greater than 5, or 5 is greater than 2, sorry, we're gonna set 5 equal to whatever the answer is for 2 plus 1, but that's 2, and now we broke the enforcement that we did in the first pass. So what we have to do, comment this out, and we just have to take the max of it. And I'm gonna run it again. Should be all green. Perfect. Get rid of these print statements. Get rid of this too, just cause. Run it again. Submit. And yeah, 100% runtime. This probably isn't the most memory efficient option. But yeah, you guys the job done, and it's pretty simple for interviews. So yeah, thanks guys.